Hello guys, welcome back to our channel. Today we are starting with our another chapter and fourth lecture of this series, that is thermal properties of matter. In this we are going to learn about all the formulas which are important in this. So now please subscribe our channel, hit the bell icon and do comment. Let's begin with thermal properties of matter. So conversion of temperature from one scale to another. This is the basic one which we need to know about this. So over here everything is given. Let me Tc minus 0, Tf minus 32, Tk minus 370, 273 minus 0.5, and so this is the change you can do over. This is F is for Fahrenheit, K is for Kelvin, and C is for the degree Celsius. So if you want to change to Kelvin, so you need to add 273.15, and over here how it is given, you can change it in this way. If you have given a formula of Kelvin, so you can put up in this and you can find out the values. Now coefficient of linear expansion, important. Alpha is equals to LT minus L naught divided by L naught into change in T. So now here LT is equals to L naught 1 plus alpha into change in T. This is also easier to understand. Okay, L naught is length of rod at 0 degrees Celsius, and L of T is length of rod at T degrees Celsius over here. Change in T is a rise in temperature over here. Now coefficient of superficial expansion or areal expansion is, so beta is equals to AT minus A naught divided by A naught into change in T over here. Now coefficient of cubical expansion, so which is gamma, is equals to Vt minus V naught divided by V naught into change in T. So here we can write Vt is equals to V naught 1 plus gamma change in T over here. So V naught is volume at 0 degrees Celsius and Vt is at volume at T degrees Celsius. Relation between alpha, beta and gamma. So alpha is equals to beta by 2 equals to gamma by 3, and this is important. This can be asked. So 6 times of alpha is equals to 3 times of beta is equals to 2 times of gamma. This is important, and this can be easily help to you in solving the answers. Now we have Q is the amount of heat flowing then. So it is easier. Q is equals to Ka theta 1 minus theta 2 into T divided by L over here. So K is a proportionality constant, theta 1, theta A. Let me write one. K is equals to proportionality constant over here. Theta 1 minus theta 2 is equals to temperature difference. T is equals to time. L is equals to length of the rod, and A is equals to area of cross section. A is equals to area of cross section over here. Now proportionality constant K की वैल्यू भी पता होनी चाहिए. K अगर हमें नहीं दिया proportionality constant तो हम कैसे निकालेंगे, तो K का भी फॉर्मूला है. सो K इज इक्वल्स टू Q इंटू L. इसको ये रीअरेंज किया बेसिकली, बाकी कुछ नहीं. A इंटू theta 1 minus theta 2 divided by T. So you can find out like this way also. Now Charles law, Boyle's law, laws पढ़ लेते हैं. So in this Charles law is pressure constant. Pressure constant means volume is proportional to T. So it will be V1 T1 V2 T2. ये हमारा इस तरीके से, and this will be constant. Now pressure law, which is Gay-Lussac law, volume is constant. In this volume is constant, so pressure is proportional to T. So P1 T1 T2 T2 divided by, this is equivalent to constant. Now Boyle's law, in this temperature is constant, so pressure is inversely proportional to temperature. So P1 T1 is equals to P2 T2, and which is equivalent to constant over here. Now ideal gas law, which is most important, PV is equals to nRT, and this will be always needed for you to solve the questions and further studies also. So please remember this. Now let's go into specific heat capacity, which is denoted by S is equals to change in Q, M into change in T. Here in some I have put up the notations what it is, so it will be easy for you to understand. If it is not there, I'm doing it. So Q is amount of heat absorbed or given out of the substance, M is the mass of and change in temperature. Molar specific heat capacity of a gas at constant volume. So it will be CV is equals to M cross S into V. So CV is molar specific heat capacity at constant volume. That is why over here V molecular weight and principal specific heat capacity at constant volume. Now we have molar heat capacity of gas at constant pressure. Let me write it over here only. So Cp same रहेगा, Cp into M cross S into P same, nothing will change. Here it was for the volume, so we write V, and here it is for the heat capacity at constant pressure, so we write over here pressure. So now thermal resistance RT is equals to X into X divided by K into A, and Newton's law of cooling. This is also an important, remember this, questions can be asked on this. So dt divided by smaller t is equals to C into T minus T naught over here. So where here dt is rate of loss of heat, rate of loss of heat. T, this is a temperature difference, this is the temperature difference, and C is a proportionality constant. Now remain is molar specific heat capacity of a gas at constant pressure, which we did over. Now latent heat, Q is equals to M into L. Q is equals to heat observed or released. M is equals to mass of a substance undergoes a change from one state to another, and L is a latent. So Q is equals to M into L. So by this we have completed this chapter also. So please subscribe our channel, hit the bell icon, and do comment and share it with your friends.